Hello friends, I welcome you all in my series of lectures on radar engineering. In today's lecture, we are going to see about non-coherent MTI. In the previous lecture, we have seen the two types of the MTI radars, that is power oscillator MTI radars as well as power amplifier MTI radars. Now both the MTI radars are having one common factor, that is they are having a coherent oscillator to stabilize the phase or to stabilize the frequency for the operation. But these oscillators or maintaining these oscillator is a problematic one. So people are going for a non-coherent radar where coherent oscillator is not there. So we are going to see about this non-coherent MTA radar in this today's lecture. The composite echo signal from the moving target and the clutter fluctuations in both phase and amplitude. So whatever the echo signal we are getting from the moving target, that will fluctuate in both phase and amplitude. That is, it will have the variations in both phase and amplitude. The coherent MTI and the pulse Doppler radar make use of a phase fluctuations in the echo signal to recognize the Doppler component produced by moving target. In these systems, the amplitude fluctuations are removed by the phase detector. The operation of this type of radar, which may be called as a coherent MTI, depends on a reference signal at the radar receiver that is coherent with the transmitter signal. It is also possible to use the amplitude fluctuations to recognize the Doppler component produced by the moving target. MTI radar, which uses the amplitude instead of a phase fluctuation, is called non-coherent. It has also been called as externally coherent radar. The non-coherent MTI radar does not require an internal coherent reference signal or a phase detector as does the coherent form of a MTI. Amplitude limiting cannot be employed in the non-coherent MTI receiver. Hence, the desired amplitude fluctuations would be lost. So, amplitude limiter is not used over here. Now we will see the block diagram of this non-coherent MTI radar. It consists of a power oscillator. It consists of a modulator to generate the pulse. It consists of a duplexer or transmitter receiver switch to connect to the antenna. It consists of one local oscillator that is used to generate the IF signal from the received RF signal with the help of mixer, and it consists of an amplitude detector. So the detector following the IF amplifier is a conventional amplitude detector. The phase detector is not used since the phase information is of a no interest to the non-coherent radar. The local oscillator of the non-coherent radar does not have to be as a frequency stable as in a coherent MTI radar. The transmitter must be sufficiently stable over the pulse duration to prevent the bits between the overlapping ground clutter. So to reduce the ground clutter, transmitter must be sufficiently stable for the particular pulse duration. But this is not as severe a requirement in case of a coherent radar. So this is not as severe as in case of a coherent radar. So in the coherent radar, we are using stylo-colo. Here we are not using stylo and colo oscillators. The output of an amplitude detector is followed by an MTI processor, such as a delay line canceller. The Doppler component contained the amplitude fluctuations may also be detected by applying output of amplitude detector to an uh, delay line canceller. The amplitude fluctuations due to the Doppler produce a butterfly modulation similar to that, but they ride on the top of the clutter echoes. The advantages of the non-coherent MTI is its simplicity. Hence, it is attractive for those applications where the space and the weight are limited. Its chief limitation is that The target must be in the presence of the relatively large clutter signals if the moving target detection is to take place. Clutter echoes may not always be present over the range at which detection is desired. The clutter serves the same function as does the reference signal in the coherent MTI. If the clutter were not present, the desired targets would not be detected in case of a non-coherent MTI. So it is possible, however, to provide a switch to the disconnect the non-coherent MTI operation and revert to the normal radar whenever sufficient clutter echoes are not present, because it can detect the target within the clutter only. So we can provide a switch, or we can provide such a system that we can switch in between coherent and non-coherent operation. Thank you.